Well, hi, welcome to EC&M Tech Talks and the 2026 National Electrical Code. The 2026 NEC is what we're talking about today. There's been a big reorganization for the 2026 NEC, so we're going to go over that first of all. We want to talk about the practical side of it, how this reorganization of the code book is actually going to benefit you as you go out into the field and do some work. Then we'll take a look at a few of the specific important changes along the way. So let's begin with this whole concept of the new 2026 NEC and how it's organized and how that can help you. Well, let's see. Imagine that you are an electrician, electrical worker, contractor, technician, engineer, whatever, and you're building a data center. So that's been your project now probably for several months and for a good time to come as well. So you've been installing the medium voltage switchgear that comes into the facility. Some 35 kV switchgear maybe. Comes directly from the outdoor substation, right? So you've been busy doing that. You've had to do a lot of grounding and bonding and of course setting equipment in place and then connecting feeders and terminating medium voltage cable maybe and lots of torquing bus bar and maybe all of those types of things, right? All medium voltage equipment. Anything greater than, let's say, 1,000 volts, right? Now, also maybe when you're done with this part of the project, you're going to be assigned to go out and just do some general wiring. You've got a lot of 480, 277 out there, certainly a lot of 208Y 120 transformers supplying a lot of lighting and receptacles, switches, all of those type things. All of that needs to be installed. In addition to that, you have what? Oh, who knows how much distribution communication cable, right? You've got lots of communication wiring that takes place. You've got fiber optic cable that needs to be installed. You've got a lot of that, maybe category 6 cable or whatever that needs to be installed. You've got cable trays just for your communication circuitry and so on. A lot of work to be done with what we might call low voltage wiring, or what the code might refer to as limited energy systems. A lot of 24 volt control, 120 volt control, and so on and so forth. So guess what? That's how the 2026 NEC really has been revised in. They've taken all the medium voltage information and they've gathered it together into different medium or high voltage articles, however you want to use the term. In other words, anything greater than 1,000 volts AC, 1,500 volts DC is the terminology we'll see in the code. So for instance, when it came to grounding and bonding that switchgear, well, you were following different code sections and whatnot, but you had to go back to Article 250 to check on your grounding and bonding. I think it was Part 10 for systems over 1,000 volts. So anyway, you were having to move around in the code quite a bit. All of that information on how to wire the transformers and the distribution system, the lighting and receptacles and branch circuits and feeders and all of that, that remains the same. Okay? Well, it's been some of it rearranged, but that's pretty much the same. We're going to install a 480Y 277 down to 208Y 120 transformer, something like that. That's still in Article 450, okay? That type of information hasn't changed. How we wire a receptacle, that information is not changing. So that's the technical, a lot of that technical information for our common everyday distribution equipment stays the same. Now, when it came to our low voltage wiring, our communications wiring, of course we had Chapter 8. Chapter 8 was a standalone chapter. So we would have to go into Chapter 8 to find out information. And I always thought of Chapter 8 as almost kind of a separate code book unto itself, you know. And there was a lot of redundancy between Chapter 8 and the previous chapters 1 through 7 in the code book. So what they did is they took a lot of that information out of Chapter 8, actually deleted some articles, took a lot of information, they've retitled Chapter 8, it's no longer a standalone chapter, and they've taken all of that low voltage communication type wiring that we do, as well as other low voltage wiring, and they put it all together into these limited energy systems articles that we find in Chapter 7. So all of a sudden, life got easier. So if I was working in Chapter 8 and I was having to go back to Article 300 to find information on my wiring, which I would have to do, and I would have to go to Article 250, maybe to look up some information on grounding and bonding, and then back to Chapter 8 to find something else on this communication wiring I was installing, I don't have to do that anymore. It's all in these limited energy articles in Chapter 7. So overall then, for working within the NEC, life has gotten a little bit easier for me, and that's a good thing, right? It's all moving towards the 2029 National Electrical Code. Annex L is a new informative annex in the back of the 2026 NEC. And informative Annex L tells you the proposed layout for the 2029 National Electrical Code. And there's a lot more chapters, but it's still divided up so that you can find that information, work with it, whether you're in medium high voltage systems, whether you're in everyday distribution equipment, or whether you're in those limited energy systems and so forth. Now, don't get confused. Don't say, well, I don't do low voltage wiring. I work in a power plant and we wire up motor control centers. Well, let me ask you, what do? When you wire on that control circuit for that motor control center, you push a start push button, don't you? That starts a motor way over there somewhere, okay? And a light comes on, not only on the MCC, but maybe up in the control room as well on somebody's screen, and lets them know that that motor is started. So what you're wiring is a remote control signaling circuit. Remote control and signaling circuit. That's what that is, okay? So we've even got a new article on some of that information in Article 206 now. So anyway, let's jump in and start at the beginning. We'll start at Article 90. We'll look at some definitions. We'll see how the code's arranged, and we'll see how all of these systems are laid out and the new articles and rearranged articles and all of that. And then we'll go ahead and we'll jump into some of the specific information on the NEC. So let's put it all up on the screen, okay? And let's first talk about these code-wide changes. A couple things I mentioned to you. Already, we're transitioning from the 2023 through the 2026 now into that 2029 code book. And that's going to be a total restructure. As I said, go to Annex L if you need to take a look at that. It says there are three major categories. There's limited energy systems we mentioned. There's our circuits over 1,000 volts AC, 1,500 volts DC, what I've been calling medium voltage. And then we have our common power and distribution equipment systems and so forth as well. Let's begin by taking a look, first of all, at Chapter 1. Chapter 1 has been expanded a little bit. Not only do we have Article 100, which is definitions, and Article 110, which is our general requirements for installation work, but we now have Article 120. Article 120 was Article 220. It's our calculations chapter then, our calculations article, excuse me. Article 120 is for calculations for branch circuits, feeders, and services. Article 130 was Article 750. It's energy management systems. It's now in Chapter 1. And if you think about it, the reason that Article 220, calculations, was moved to Chapter 1, now Article 120, it doesn't apply just to Chapter 2, does it? It applies throughout the code. We have all kinds of locations where we're having to come up with branch circuit calculations and feeders and services and so forth. So anyway, that's Article 120 now. Part of Article 120 is that we're required to do calculations for energy management purposes. So Article 130 is energy management systems, and now that appears in Chapter 1 as well. So a little bit of expansion then of Chapter 1. Let's take a look then how these articles are working out then for the 2026 NEC. Let's take a look at Chapter 2. We just talked about Chapter 1. Chapter 2. Let's see what they did in Chapter 2. These are the articles. These, 6 articles that we have are for systems, equipment, rated over 1,000 volts AC, 1500 volts DC nominal. So we have Article 245, which is overcurrent protection for systems rated over 1000 volts AC, 1500 volts DC nominal. We have Article 265, which is for branch circuits rated over 1000 volts AC and so on. We have Article 266 for feeders rated over 1000 volts, 1500 volts DC. We have Article 267, which is for outside branch circuits and feeders rated over 1000 volts AC and so forth. Article 268 is for services over 1000 volts. And then, probably a big change for a lot of you, Article 270. So they went into Article 250, which has always been our article for grounding and bonding, right? They went into Article 250 and they pulled out the information for over 1000 volts AC, 1500 volts DC, and they put that into a new article, Article 270, for grounding and bonding for systems rated over 1000 volts AC, 1500 volts DC nominal then. So those are new articles that we find in Chapter 2. And so once again, if you're going to be doing, say, installing that medium voltage switchgear, working on anything over 1000 volts, you're now going to find that information grouped together for you in those articles. We still have, has not changed, we still have Article 305, which is the general requirements for wiring methods and materials over 1000 volts AC, 1500 volts DC. And we still have Article 315, which is for medium voltage conductors, cables, cable joints, and cable terminations, and over 1000 volts, right? And we still have Article 495 for equipment rated over 1000 volts AC, 1500 volts DC. So now, logically, your systems, equipment that you're working on over 1000 volts AC, 1500 volts DC, it's all been grouped together for you in those various articles we just mentioned. Now, as far as these limited energy systems, there's a new definition in Article 100 for limited energy. And it talks about power being restricted or limited, or to shut off the power if need be. So what is it talking about? By restricting or limiting the power in a circuit, it's not as, think of it as not as dangerous, right? The whole purpose of the code is to prevent electrical fires and to prevent people from getting shocked and electrocuted. So if we're dealing with limited energy systems, maybe we're talking about systems that there just really isn't enough energy for, to normally get a shock. Say you would normally get a shock at 30 volts or 24 volts or something like that. And the total amount of energy is really not enough to cause a fire. So limited energy systems. So if I'm going to work with circuits like that are safer, maybe I don't have to follow the same requirements that I do for installing that 480 volt three-phase circuit. Oh, where I've got lots of energy, right? I could quickly, unfortunately, burn down a building or certainly injure someone very quickly with 480. So these limited energy systems then have some different restrictions and requirements. No longer do we have to jump into Article 300 and Chapter 8 and other things in Chapter 7 and so forth. It's all grouped for us now in these limited energy systems. So what are these new articles then for limited energy? Article 720 is the general requirements for limited energy wiring methods and materials. Very closely parallels the types and articles or the types of information and sections that you would find back in Article 300 for some of our general wiring requirements. But anyway, Article 720, general requirements for limited energy wiring methods and materials, a new article. Another new article is Article 721, power sources for limited energy systems then. Article 722, limited energy cables. That also includes optical fiber cable. So Article 770 was on optical fiber cable. It was a pretty lengthy article. That article has been deleted. Article 770 on fiber optics no longer exists, but the information's still there. What they've done is they've taken that information and they've put it into Chapter 7. So we'll find information in Article 722 on fiber optic cable as well as other types of limited energy cables. Now, Article 723, the new article, is on raceways, cable routing assemblies, and cable trays. There are some difference in construction there between what we find for our normal distribution wiring. Article 742 is for over voltage protection for limited energy systems. And there's Article 750. They've taken that information for grounding and bonding for these limited energy systems, and they have grouped it together for us in Article 750. Some other new articles. I mentioned this a little bit earlier. Article 206, non-power limited remote control and signaling circuits. What's that talking about? That's talking about my motor control circuits, a lot of my motor control circuits. They're non-power limited. So now I take and I push the push button. Maybe I'm applying 120 volts to a 480 volt motor starter. When that contacts in the motor starter go closed, that supplies 480 volts to the motor, and we said the motor over there runs. At the same time, some lights come on different locations, let people know that that motor's running. So that's the signaling portion of my circuit. So remote control and signaling is a separate article now that really wasn't addressed very well in the code before, Article 206. Another new article is Article 624. It's an addition to the new articles we've been talking about. Article 624 is electric self-propelled vehicle power transfer systems. Well, that's a little different from the previous article that we still have in the code book on our electric vehicles. So we have our electric self-propelled vehicles that are not on the road. We have forklifts. We have golf carts that run all over and so forth. All electrically driven, now covered in Article 624. Article 235 was deleted. Now, don't panic when you see these articles are deleted. It just means the information was probably relocated somewhere else as need be. So branch circuits, feeders, and services over 1,000 volts, AC 1,500 volts. Well, all of that information was grouped together in that Article 235. That's now been broken out into different articles, as we just saw. Article 395 was on outdoor overhead conductors over 1,000 volts. Once again, information relocated. We just mentioned Article 770, optical fiber cables, has been deleted, and Article 805 on communication circuits and 840 on premises powered broadband communication systems has been deleted as well. Once again, though, information relocated in that Chapter 7 on limited energy systems. Informative Annex E and Informative Annex J were also deleted in this code. Why? Well, Informative Annex E was types of construction, and evidently a lot of people had problems with the information that was in there. Annex J was the ADA, Americans with Disability Act standards for accessible design. And just kind of the way that the NFPA normally does business is that if I have information, I don't want to duplicate information in one code here and another code here. Then when it changes in this code, I got to run over and make sure it's up to date in this one. So that's what was going on. There have been changes to the ADA standards. Best is to go ahead and delete the information. If you need the ADA standards, obviously, as you do when we design and build buildings, then you go to the appropriate ADA information that you would need. And then I mentioned earlier that new Informative Annex L. Go ahead and take a look at that when you get a chance. Kind of see where you're going with the 2029 code. Wow, okay. But keep in mind, take a look at the groupings of that information. You'll go, well, wait a minute. Chapter 1 and Chapter 1, they kind of look alike. And this other information should fall into place for you based on what we're learning today about the 2026 NEC then, okay? Some of the other global changes. The article number .2 then would be any listing requirements that apply. And we've seen this, changes from definitions moved to Article 100 in previous code editions. But now, so the article number .2 is any listing requirements that apply, and .3 is on reconditioned equipment. Do pay attention to those two. There have been changes. Some things are required to be listed now that were not previously. Reconditioned equipment. It is more specific in some articles than it was previously as well. We're also seeing more use of acronyms in the code book. You know, OCPDs and so on, and SPGFCIs and all that. Imagine that. So probably a lot of you have access to the NEC online through the link on NFPA that you can go to and you sign up for on NFPA. But anyway, that allows you access to the NFPA codes and standards online. So if I think about it, okay, I want to do an online search. I know there's some requirements out there on these special purpose ground fault circuit interrupters. So I'm going to go ahead and I'll go to chapter 2 and link, and I'll type in up at the top under search. I'll search for special purpose ground fault, you know, and off I go. And I'm probably going to get the hyphen in the wrong place anyway, right? So if I can just type in SPGFCI, oh, that's a lot quicker then, isn't it? Rather than type in circuit breakers and fuses, I can just type in OCPD, right? So it just kind of makes sense then to use more acronyms when we start talking using the internet, right? Online stuff, okay? 240.7 helps clarify. It's a new section in Article 240, and it gives us more direction on overcurrent protected devices. It lists 6 of them that says, hey, these are overcurrent protected devices, because we never really spelled that out very well in Article 240. I always said, well, 240 is on fuses and circuit breakers, right? Well, obviously it's more than that, but it lists the 6 types of overcurrent protected devices that we use to protect our branch circuits and so on. We all know molded case circuit breakers, low voltage power circuit breakers, solid state, and what does it say? Solid state hybrid circuit breakers. Wow. Specific fuse types, plenty of those. The old Edison-based fuse, type C or type S fuses. And then, that term that we often see, other fuses are circuit breakers labeled as suitable for the application then. Right? So anyway, that list, take a look at that in 240.7. Now, let's take a look, back up a little bit into Article 90, which is the introduction. And now that we've looked at some of these global changes, let's see how the code is now laid out. So this is a little reproduction then of the figure 90.3 on code arrangement. Over on the left-hand side, you can see this is all pretty much the same, right? Well, it is. Chapter 1, 2, 3, and 4. No changes there. It says applies generally to all electrical installations. And that's true, chapters 1 through 4. Chapters 5 through 8, look at this. 5 through 8 have been retitled. Instead of saying special, they've now gone to the word specific, which makes more sense, right? It's not special occupancies. We're talking about specific occupancies. It's not special equipment. It's just specific equipment. Whether it's a crane and a hoist or an elevator or whatever it is, it's something specific. All those rules in 1 through 4 apply, but sure, we may end up, modifying them with this information in chapters 5, 6, and 7 like we've always done. Chapter 7, once again, that word specific appears. So specific conditions and systems in chapter 7. And in chapter 8, it's no longer a standalone chapter. In fact, they have retitled chapter 8. It's for communication systems outside the building then. In other words, we're talking about we come in from the utility, from the serving utility for our communication system. We come in, some way we get into the building, wherever, some kind of penetration or something, right? We come into the building and we go to what you'd say, well, it's not service equipment. No, some type of maybe network interface or something like that, where we're now going to distribute that communication wiring out into the rest of our building. So anyway, that's what chapter 8 is now. So chapter 8 has been drastically reduced in size, but the information now we just find where? We said in chapter 7, those limited energy systems. Our informative annexes we've talked about. Chapter 9 is still our tables. That hasn't changed. New definitions. So these are all new terms we're going to find in the NEC. So we got to get used to them, right? Hey, how about cable tie? You ever talk about cable ties in the field? We use them all the time, every day, all over the place for all kinds of stuff, right? But when it comes to electrical wiring, the use of cable ties, we now have a definition for cable tie. Take a look at this stuff. It's fun to look at these new definitions. How about a cable tie fixing device? I need some way I'm going to take these cables and bundle them together, or wiring and bundle it together. And then I need to, in the enclosure, I want to attach that cable tie to the enclosure, so I have a cable tie fixing device. Conductive pavement heating systems. We've been installing these, it's just we really haven't had any real rules for those. We'll see in other articles there's actually a new part in an article that talks about conductive pavement heating systems. We have a definition for it now. Electric self-propelled vehicle supply equipment, ESVSE. Even though it's a little confusing, it's still probably easier to type in than to go through and try and type all of that in when you're searching on the link website. Electric self-propelled vehicle, once again, electric self-propelled vehicle power export equipment. And this is power export equipment. This is where we can take our electric vehicle and we can put electric power back into our distribution system. Definition for generator terminals. We use that term all the time. We talk about it. We need to know, we need a definition so that when we're talking about generator terminals, we know exactly what the reference is to that. Note that note over here. You're going to see this on probably all the remaining slides. As we start going through specific information now in the code book, it's a very general, very brief explanation of these changes that are taking place in the code. You notice on these definitions, I'm not going through and reading the definition to you and explaining. That takes time, certainly with all the changes we're going to go through. Okay? There's a 2 or 3 days worth of training if you really want to go through some type analysis on all of these different code changes then. But we're seeing where the 2026 code is going to take us, right? So for GFCIs, we have some new definitions. We have for the GFCI, ground fault circuit interrupter, right? We've revised that definition. We've added the term Class A to it. So we have Class A, B, C, D, and E GFCIs. And they perform different functions for us. So we just had to start spelling that out, all based on the UL standards then. Ground fault circuit interrupter, special purpose, Class D, and so forth. So we find the requirements where primarily in Article 210, 210.8 is where we find most of our GFCI requirements. But as always, if you really want to know about ground fault circuit interrupters, GFCIs, ask yourself, okay, to use the code book, 2026, it hasn't changed. I need to know something about, what's your question? GFCIs. I got a question on where I need to install a GFCI. Don't just go to 210.8 and expect to find the answer. Go to your index in the back of the book. Look up ground fault circuit interrupters, GFCIs. You'll find a whole list of information. Maybe it's specific for a swimming pool or a fountain or something like that, another location, hazardous locations and all of that. So take a look at your index anytime you have a question you're trying to find information. First ask yourself, what is the question about? Is it about GFCI? Is it about swimming pools? Is it about branch circuits? Whatever it is, go look that up in the index. You'll find a whole bunch of information. Then, of course, find the appropriate article section number that you need and go there and interpret the code, right? Hey, ground fault circuit interrupter, special purpose, Class E, and all of that. Okay? More new definitions. How about this? Line to ground, line to line, and line to neutral. Well, we understand what that is. We talk about that all the time, don't we? Pretty sure we got a handle on that. Go take a look at it. In Article 100 now, it's now defined for us. Power control systems, PCS, and then new term for transformer secondary conductors. I guess we've talked about it. I come off the secondary. If it's step down transformer, I'm taking the low voltage off the secondary coming off the secondary windings or whatever it is I'm doing, and off I'm going, right? Now we've got a term, transformer secondary conductor then. Take a look at Article 110. Article 110 is general requirements for electrical installations. Now let's look at some of the specific changes in the code, and we'll do that for the rest of the presentation then. 110.3 now prohibits manufacturer's instructions from reducing NEC requirements. Okay, should make sense to us. The change suitable in 110.14 has been changed to identified. Once again, suitable is kind of nebulous term. Well, it's suitable to me. Why isn't it suitable for you? Okay, so now it says it has to be identified. And we do have a definition in Article 100 for identified, don't we? They've made some clarifications on where the high leg marking must be in 110.15, that orange color. 110.16 is on our arc flash warning labels. And that's been expanded. The information that's required. So that affects really your NFPA 70E training as well for electrical safety. So expanded requirements on your arc flash warning label. I think it's a good thing because it's always been, in the past it just said you have to put the label on the equipment and so on and so forth, and go take a look at 7E if you need to know more about it, the informational note there. Now it's telling you specifically, hey, this is the information that the people need to be safe when they go out into the field. So that's a good thing. 110.17 now makes it clear that the installation is covered by the NEC, but maintenance is covered by 70B. So that people somehow don't get... In fact, I had a phone call earlier this morning. A fellow called me up from overseas asking about maintenance requirements in the NEC. We don't address maintenance in the NEC other than right at the beginning back there in Article 90, right, where there's some explanation about assuming we're going to maintain our equipment to keep it safe. But the actual maintenance requirements are covered by the NFPA 70B standard, which was revised not long ago, and it moved from a recommended practice to a standard, which means it went from, hey, it's a good idea, we recommend you do this electrical maintenance on your equipment. Now it's a standard, meaning it's an ANSI approved standard. It'll stand up in a court of law. Hey, this is the maintenance the maintenance you must do on your electrical equipment. And if you don't do it, there's no maintenance police that are going to come looking after you, right? But if something fails, somebody gets hurt, you have a fire or whatever, there's going to be questions about enforcement of NFPA 70B, certainly. 110.26, of course, has always been an important one in the code. And that is for our working spaces about our electrical equipment, height of working space and distances, so on and so forth. So anyway, there have been some significant changes there. One, clarification of the measurement process for determining the 24-inch clearance requirement. And this is on your door opening. So if I have a door opening, and the whole idea is that even with the door, so when I open up the door and it's 90 degrees like this, I've still got to have 24 inches to go running down that walkway or whatever, go running down there and get out of that electrical room if something's wrong. And so that door, when it's fully open, cannot come into that 24-inch area. When it's, well, I shouldn't say fully open, when it's open 90 degrees perpendicular to the equipment then. Take a look at your changes on depth of working space then, and they've added feeder disconnects to the rule as well for spaces about feeder disconnects. So 110.26, especially important one in the installation world, make sure you meet those new requirements. Article 120 we said was relocated from Article 220. It's our branch circuit, feeder, and service load calculations. We still do calculations. There have been some changes. There's a new subsection on DC, and we see this throughout the code, right? We have more and more DC systems being installed, more and more DC power out there. So we see more and more information in the code, new sections, subsections, and so forth throughout the different articles referring to DC. So pay attention to DC. Now, there's always been some question on about that 125% multiplier. If I have a continuous load, you take 100% of the non-continuous and 125% of the continuous load. Definition in Article 100 for continuous load. Anyway, further clarification now on 120.5 for explaining that 125% continuous loads. That's a good one to take a look at. says several adjustments made to dwelling unit calculations. Yes, several of those. So take a look at, if you get involved in calculations, services, branch circuits, feeders, certainly probably do for branch circuits and feeders, take a look at Article 120 changes. Let's take a look at some of the changes in Chapter 2 for wiring and protection. So there's a requirement in the code book on a service that where my line terminals come in, I must have some type of protection over those line terminals. Because even if I shut off the main breaker down here, those line terminals coming in from the utility are still hot, energized, aren't they? So we must have barriers in place. Well, those barriers must be identified for that particular use, that particular panel, board, whatever it is. Disconnect location and markings, 230.70's covered the disconnect always, right? We now have more information for the location and the markings on that disconnect. 240.24, okay? Well, you can't do this. Overcurrent protective devices and bathroom panel boards. No, we don't today, we don't go and install panel boards in bathrooms, do we? However, if you have an existing installation and it already has a panel board in the bathroom, and that was installed and approved, whatever, before the requirement prohibiting that panel board inside of that bathroom. So if you meet those requirements, then the question was, well, can I put an overcurrent protected device? Can I add another, fuse or circuit breaker into that panel? And the answer is yes, if you meet that requirement for the previous installation then. Well, another thing we've seen now in Article 250, and some changes in Article 250, I'll tell you right off, right? They took all of that medium and high voltage information out and moved it elsewhere, and some of the limited energy information and so forth. But anyway, what they did, 250.4 is very important. 250.4 tells us why we ground and bond. And it tells you, so that we stabilize the voltage to earth during normal operation and so on and so forth, and why we bond and all this. So 254, lengthy session. One of the things they've done in 250.4, which they've done throughout the code, which I really like, so rather than have this big long paragraph that tells me, well, okay, let's see, why do I have to ground and bond? Let's see. Oh yeah, sentence number 3 says, they just put it into a list for me. So here's your reasons. Boom, boom, boom. 1, 2, 3. Okay, there we go. Makes it a lot easier to read and decipher and interpret and so forth. 250.64 changed there. So we've always had to run that grounding electrode conductor, continuously and so forth. Now allows us to splice the grounding electrode conductor. Just don't run out and do it though, okay? Take a look at the specific requirements for that in 250.64. In Chapter 3, what are some of the big changes in Chapter 3 then? Once again now, read that note on the right, okay? This is a very brief look and some examples of just simply some of the major changes that we're seeing. Once again, plan to spend lots of time researching these, making sure you get a good handle on all these changes as they apply to you. So 300.4C requires damaged wiring be replaced. Well, yeah, we do that anyway. Well, you better take a look at 300.4C then. So what is damaged wiring and what are my requirements for replacement on it? Interesting change, I think, 300.4C. Another new one, 300.11B, raceways and wet locations above grade are required to drain. We've always known conductors inside a raceway, inside a conduit in a wet location. Inside the conduit, still considered a wet location. Now 300.11b says it has to be, it's required to be able to, that raceway drains, righty? 310.15e clarifies that, or clarifies when the neutral is to be considered a current carrying conductor. Always been interesting in the code book, right? Where we do calculations. Oh, is the neutral a current carrying conductor or not? Well, I don't, blah, 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 and so on and off we go. Get some more clarification now, 310.15e. Hey, the table, our ampacity table, 310.16. This was always a little confusing anyway. XHWN has been removed from the 90 degree C column. It's a 75 degree C wire. Makes sense. There's only one H in there. One H is 75 degree. Two H's normally indicate 90 degrees C. XHWN is now just in the 75 degrees C column. 312. Let's go to Article 312 on our cabinets and cutout boxes and so forth. And it says I can't recondition cabinets, cutout boxes, meter socket enclosures. So that's a change. 314. So box fill calculations, right? Always the question, well, how about, I got some pretty big wire nuts in there. Come on, that takes up some space in that box. Yeah, you're right, it does. Okay. But do we count it in our box fill calculations? Some said yes, some said no. The answer now, 3.4.16, no. Wire nuts are not included in box fill calculations. And that includes if you're using a little push-in square, or when you push the clamp down and lock it in place, whatever. Those are not used in box fill calculations. Staples throughout these on these cables, so whether it's NM cable, MC cable, whatever it is you're using, if you're using staples, it just said dot 30 was always, or it is, securing and supporting, right? And dot 30 says, hey, to secure and support, you may use, and it said staples and listed the other means. Now it says our staples have to be listed. So you got to get listed staples to support that NM wiring, whatever it is you're doing. 342.29 on intermediate metal conduit, IMC. So on type IMC conduit, when I take and I put a piece of IMC conduit into a box, I have to use paired lock nuts. In other words, put a lock nut on either side of the box and tighten them down. That's a requirement with IMC now. Non-threaded openings, 2 lock nuts. 392 is on cable trays, right? 392.18 now specifies some height clearance requirements above the cable trays. So that can be a pretty important one, as you know, especially if you had to ever work in a cable tray, okay, after installation. So take a look at 392.18. Take a look at Chapter 4 now. Chapter 4, Equipment for General Use. What are some of the changes we see? Snap switches, okay, our light switches on the wall, have been moved from Article 404 to 406. Why would they do that? Because they belonged in 406. I don't know why they were in 404, whatever. But now Article 404 is for our general use switches. Anyway, 422 on appliances applies to all types of occupancies, not just dwelling units. At 422, it now lists loads that can be connected to the branch circuit for central heating. That has been expanded. Okay? So if you're involved in any of that. Water heaters made it clear that water heaters greater than or equal to 120 gallons are continuous loads. So if I have an electric water heater greater than or equal to 120 gallons, it's a continuous load. But yeah, mine cycles off and on and doesn't run for 3 hours straight. Hey, continuous load, all righty? 426, conductive pavement heating systems must be listed. We already saw the new definition for these conductive pavement heating systems, and now there's a new part in Article 426 has been added to address these conductive pavement heating systems. Article 430 is on motors. 2 additional design motor. We've always seen, design B, design D, whatever. We now have design BE and design CE. So those have been added throughout Article 430 wherever they needed to add information on design motors. 430.3 specifies the requirements for reconditioning motors. Hey, I've always sent motors out to the rewind shop, no big deal, huh? Take a look at 40.3, make sure you're meeting those requirements. 430.98, MCCs, motor control centers, must be marked with the disconnect location to de-energize all the power to the MCC. That's a good safety thing. I got to lock out, tag out this MCC. We got to get in the back and do some work on the bus work or whatever it is. I want to make sure I get all my sources of power. Good way to start, look at the front of that equipment, look at the labels, and find out where all your disconnects are located, what's supplying power to that MCC. It could be more than just that 480 coming in. Hey, also, I didn't mention it, but back in, where would it be? It would be, I guess, in Article 120 now, okay, on 416, 240 volt systems has been added as well on voltages. And let's see, Article 440 on our heating, air conditioning, and refrigerating equipment. 440.11, doors must be locked if energized parts can be exposed. So if I can open up the door and be exposed to energized parts, that door either has to be locked or require some type of tool, whatever it is, screwdriver or something, Allen wrench, whatever, in order to open it up. Split systems, okay, and HVAC equipment. So our split systems, disconnect marking requirements. Makes sense. I've got a split system. I've got two different pieces of equipment. I have a requirement now for marking the disconnects for that equipment, 440.15. Now, chapters 5 through 8. Let's wrap up here with chapters 5 through 8. First of all, we already mentioned all of those chapters, 5, 6, 7, and 8. So that's 4 of them, right? Okay, all 4 of them have been retitled. We see the word specific now. Chapter 7, we find a lot of information now on our limited energy systems. Chapter 8 is no longer a standalone chapter. So all of that information I had in chapter 8, for instance, in chapter 8, what was it, Article 800, I guess? It said that all my work had to be done in a neat and workmanlike manner. And back in 110, it said it has to be done in a professional and skillful manner. Well, you can just get rid of that requirement in chapter 8 now, because the whole code applies to the communication system limited energy wiring. Okay? Got to do it in professional and skillful manner, all righty? So chapter 8 is no longer standalone. The information that in there has been relocated. Where do I find that relocated information? A lot of it then is in chapter 7 on my limited energy systems, those new articles we talked about earlier. Several new and many revised technical sections and subsections throughout 5 through 8 then. We've seen the deletion of articles in chapter 8, but even in the remaining articles in those chapters, 5 through 8, obviously you're going to find technical content changes. So as appropriate for whatever specific occupancy systems, equipment, whatever it is you're working on, take a look at that information then. Make sure you're up to date on 5 through 8. That, in a nutshell, was a lot of time, but that is the 2026 NEC. So, if you really need to know the 2026 NEC, right, you're going to need some additional training on all of those changes. Or do it on your own, or however you're going to do it. But you're going to have to spend some time in this book going through there and finding out the changes that are applicable for you, or whether you go through a training course, cover the whole book or whatever. Okay? The main thing is that you apply those changes. Why? Because they prevent fires and prevent people from getting electrocuted. That's real important stuff. That's why we have the National Electrical Code. So, until the next Tech Talk, work safe.